laboratory in Colorado, 6 laser beams cross inside a vacuum chamber. Where they meet, a cloud of atoms freezes, slowed to a crawl, a whisper above absolute zero. Then the light gently tosses it upward, a fountain of atoms, rising and falling in the dark, about a meter high. This is a clock. It will not gain or lose 1 second in 300 million years. And the strangest part is why it exists. Because for most of human history, not knowing the exact time didn't make you late. It got you killed. This is The Perfect Objects, the series about the most perfect things human beings have ever made. Episode 2, The Perfect Clock. October 1707. A British fleet is sailing home through fog and foul weather. The navigators believe they are safely west of any land. They are wrong. In the dark, the fleet runs onto the rocks of the Isles of Scilly. The flagship goes down in 3 or 4 minutes with all 800 of her crew. By morning, 4 ships are gone, and somewhere between 1,400 and 2,000 men are dead. Not because of the storm, because nobody aboard could answer a simple question. Where are we? At sea, the sun will tell you your latitude, but longitude, how far east or west you've gone, defeated everyone. So in 1714, Parliament put a fortune on the table, 20,000 pounds, millions in today's money for anyone who could solve it. And the answer in the end was a clock. Here's why. The Earth turns 15 degrees every hour. So if you carry the exact time from back home and compare it with local noon wherever you are, the difference tells you precisely how far around the world you've come. Know the time, and you know where you are. But a pendulum clock is useless on a rolling ship. The prize needed a clock that could survive the sea. A self-taught carpenter named John Harrison spent decades on it. His early machines were beautiful brass monsters. His masterpiece, H4, looks like an oversized pocket watch, ticking 5 times a second. In 1761, it sailed to Jamaica, and by most accounts, it lost only about 5 seconds in 81 days at sea. It met the strictest terms of the prize. A carpenter had solved longitude with a watch. Because every clock is just 2 parts. Something that swings, and something that counts the swings. Better swing, better clock. For nearly 3 centuries, the best swing was a pendulum. Christian Huygens built the first pendulum clock in 1656, and by most accounts, it cut a clock's daily error from minutes down to seconds. Pendulums stayed the most precise timekeepers on Earth until the 1930s. Then the swing shrank. Inside every quartz watch, a tiny crystal tuning fork vibrates 32,768 times a second. Exactly 2 to the power of 15. So a simple circuit can cut it in half, 15 times over, down to 1 tick per second. Quartz drifts about 15 seconds a month. Good. But the perfect swing turned out not to be a thing at all. It was an atom. Every cesium atom in the universe is identical, and each one carries a perfect swing. Tickle it with microwaves at exactly the right frequency, and it flips between 2 energy states, 9,192,631,770 times per second. Never faster, never slower. The same in every atom, everywhere, forever. The first cesium clock was built in 1955, and since 1967, that number has been the definition. 1 second is 9,192,631,070 swings of cesium. Today's fountain clocks work the way this film began. 6 lasers freeze a cloud of cesium atoms to a whisper above absolute zero, slowing them to a few centimeters per second. Then the light tosses them a meter upward, Through a microwave beam, up and back down a fountain, to read the swing as purely as physics allows. The result will not drift 1 second in 300 million years. And it is not even the good one. To build a better clock, you need a faster swing. So the newest clocks abandoned microwaves and started counting light itself. Visible light oscillates around 500 trillion times a second, tens of thousands of times faster than cesium's microwaves. In a lab in Colorado, a few thousand strontium atoms hang inside a lattice of laser light, a stack of about 400 glowing pancakes, while an ultra-stable red laser reads their tick, hundreds of trillions of beats every second. A clock like that wouldn't gain or lose a second in 15 billion years. Roughly the age of the universe. To be clear, it hasn't run that long. That is simply how precise it is. And sometime around 2030, the second itself will likely be redefined. The cesium standard retired and time handed over to light. So, what do you do with a clock that perfect? You discover it was never really measuring time. You carry the proof in your pocket. The blue dot on your phone comes from navigation satellites, and every one of them carries atomic clocks. Clocks that run fast, by 38 microseconds a day, exactly as Einstein predicted, because gravity is weaker up there, and time itself runs quicker. 38 millionths of a second sounds like nothing. Ignore it, and your position is wrong within 2 minutes, and drifts by 10 kilometers every day. And it goes deeper. In 2010, physicists raised one clock above another by 33 centimeters, 1 foot. The higher clock ran measurably faster. Your head really is aging faster than your feet. So the perfect clock has quietly become something else. A ruler. 2 clocks, one a centimeter higher, now tick at measurably different rates. A clock can read height, can read gravity itself. 300 years ago, we built clocks to find out where we were. We perfected them, and that is still exactly what they tell us. Next time, the roundest object on Earth. Subscribe. The series is just beginning.